You know that one type of math proof that always shows up on exams? The one that's designed to look super complex and kind of intimidating? Well, what if I told you there's a simple secret that lets you solve it perfectly every single time? Today, we're going to learn that secret.
Yeah, you've seen them, right? Those proofs that just seem to drag on and on. But for the very specific type of problem we're looking at today, the solution isn't long or complicated at all. It's actually hiding in plain sight. So here's our challenge. We have to prove that a mixed number like this one, a combo of a regular number and an irrational root, is irrational itself. And I get it. At first glance, proving that 6 minus 2 root 5 is irrational looks pretty daunting. Just a super quick reminder, right? A rational number is any number you can write as a simple fraction, like 1/2 or even just 7. An irrational number can't be. Think of pi or the square root of 2. And our number here is a mix of both. But here's the really good news. You do not need that super complex multi-step proof that you'd use for something like proving the square root of 5 is irrational all on its own. Nope. For these mixed numbers, the method is way faster, way simpler, and much more direct. Okay, so the whole secret, the entire technique, it all boils down to one simple, powerful action. Isolate the root. Seriously, once you understand this single move, the entire proof basically solves itself.
So, what does that actually mean? It's simple. Your only job here is to use a little basic algebra to get the irrational part, that square root term, completely alone on one side of the equal sign. You just move everything else to the other side. That's it. That is the entire strategy. Okay, enough talk. Let's actually put this thing into practice. We'll start with our first example, what I'm calling a subtraction case. We are going to prove step by step that 6 minus 2 times the square root 5 is an irrational number. Okay, so first up, we're going to use what's called a proof by contradiction. We're just going to assume the exact opposite of what we want to prove. So let's just say, for a minute, that 6 minus 2 root 5 is rational. That means we can write it as a fraction, a over b. Now we apply our big secret, isolate the root. As you can see in step 3, we just shuffle things around a bit. We bring a over b to the left and 2 root 5 to the right. Then for step 4, we tidy it up and divide by 2 to get the square root of 5 all by itself. And that leaves us with a very, very interesting equation. And this right here, this is the aha moment. Take a look at the left side of our equation. Since a and b are just integers, that whole thing is just a fraction made of integers. By definition, that has to be a rational number. But look at the right side. That's the square root of 5, which we already know is irrational. And that, my friends, leads us to a fundamental, totally unbreakable rule in math. A rational number simply cannot be equal to an irrational number. It's just impossible. So what we've got here is a contradiction. It's a statement that just can't be true. And since every single step of algebra we did was perfectly valid, the only place we could have made a mistake was right at the beginning with our initial assumption. And that can only mean one thing. Our very first assumption that this number was rational had to be false. So that means 6 minus 2 times the square root of 5 is irrational. Proof complete. See, not so bad? Okay, that was pretty cool, right? Let's try another one, but this time it's a multiplication case, and you'll see just how ridiculously fast this method can be. We're going to prove that 7 times the square root of 3 is irrational. We're going to do the exact same thing. Step 1, assume it's rational, set it equal to a over b. Step 2, our main goal, isolate the root. All we have to do here is divide both sides by 7. Boom, one move and we're there. And look at that. Just like before, we've created an impossible situation. On the left side, we have the square root of 3. We know that's irrational. And on the right, we've got a fraction made of integers, which is by definition rational. We've created the exact same contradiction. You've got an irrational number equaling a rational one. That's the contradiction. Game over. Our assumption was wrong, which means 7 root 3 has to be irrational. It really is that simple. Just 2 steps to the answer. All right, so let's just take a step back and recap the core logic here. Why is this isolate the root method so powerful? Well, it's because it is specifically designed to force this fundamental mathematical conflict, and it works every single time. Think of this slide as your cheat sheet, your repeatable game plan for getting full marks every time. The steps are always the same. You start with the opposite assumption, then you have one and only one goal, isolate the root.
This always creates that impossible situation of rational equals irrational. You state that contradiction, and boom, you have the complete logic for a perfect proof. At the end of the day, this whole beautiful, elegant method is just built to break one single undeniable rule of math. And in doing so, it proves that our initial assumption had to be wrong from the start. And that just leaves us with a really cool thought, doesn't it? We just took a proof that looks super complicated on the surface and found this simple, beautiful trick right at its heart. It kind of makes you wonder, how many other difficult problems out there are just waiting for you to find that simple core idea that unlocks everything?